As mentioned earlier, big matrices have been designed to look and feel like a regular R matrix. You can retrieve subsets of a big matrix just like you would a regular R matrix. You can also set values of a big matrix just like you would a regular R matrix. However, it is sometimes important to realize that a big matrix isn't actually an R matrix. There are a couple of differences that can be important. One difference, which you already know, is that a big matrix object is normally stored on the disk rather than RAM. This means that a big matrix can persist across R sessions and can even be shared among R sessions. Another difference is that a big matrix object is not copied like a regular matrix. When an R variable is assigned to other variables, it actually gets a copy of the content. This is also true when parameters are passed to functions. Here, we assign the value 42 to the variable a. Next, we create a function foo that takes the single parameter, sets it to 43, and then outputs its value. When we call foo of a, the printed message tells us that a inside the function is 43. When we print the value of a outside the function, it is still 42. This is because the function foo doesn't actually get a, it gets a copy of a. If we want to change the original a, we need to do so outside of the function. There are other types of variables, like environments, that are not copied when they are passed to a function. For these types, it is the actual data structure, and as a result, if you change their values inside a function, you will see those changes after the function is finished executing. Those types of objects have reference semantics. A big matrix is a reference object. This means that assignments create new variables that point to the same data. If you want a copy, you need to do it explicitly using the deep copy function. Reference behavior ensures that R won't make copies of the matrix without you knowing. This helps minimize memory usage and execution time, but it also means you need to be careful when you are making changes. Here we have an example that shows the reference behavior of a big matrix. We start by creating a new big matrix called X. We assign a new variable xNoCopy to X. xNoCopy now references the same data as X. If you update X, the changes will be reflected in xNoCopy as well. However, when you create xCopy by explicitly applying deep copy on X, then xCopy has its own copy of the data in X. So, if you change a value in X, it will not be reflected in xCopy. Now that you have seen the differences between copies and references, you get to spend a little time manipulating reference objects.